Welcome. Welcome to the control structures of statements. This is the this is very important chapter or topic in any language, not just C language. Or the main important feature of any language is control structures or statements, because it gives you control. It gives you control. What kind of control? What kind of control? Here we are interested in execution of the programs or execution of different statements or instructions in a program. So these control statements, you control over the execution of the statements. That means you can decide in what order you want to execute the statements. In what order you want to execute the statements, whether it is 1, 2, 3, 4 statements, or you execute 1 and go to 3. Maybe I don't want to execute statement 2, I go to 4, like that. Or I want to execute, say, statement 2 10 times. I want to execute, say, statement 4 if some condition is satisfied. Something is true, then I want to execute, otherwise I don't want to execute. So I want to have alternative statements. That means I execute one, I don't want to execute other. The other statement is executed, maybe the previous statement is not executed. The previous statement is not executed. So these control statements provide you an opportunity to control the execution of other statements. Control the execution of other statements. So before we get into the control statements or control structures, so let us discuss unstructured and sequencing. Let us discuss what is called as unstructured programming and then sequencing. Unstructured and sequencing. So by default, the order of execution of statements, the order in which statements are placed physically. So if you place the statements, say S1 is one statement, S2 is another statement, S3 is another statement, then generally the order of execution of statements is S1 followed by S2 followed by S3. That is the order in which you have placed the statements physically, and the order of execution statements will be same as that of this physical placement of statements. So S1, S2, S3. So the order of execution of statements is the order in which the statements are placed physically. But what if you want to execute certain statements based on some condition? If some condition is true, I want to execute S2, otherwise I don't want to execute. What if I want to execute, say, statement S3 several times based on some condition or some fixed number of times? So C supports these features using control statements or control structures. So control structures are those which control the execution of other statements. Control structures or control statements are those which control the execution of other statements. There are three types of control statements: sequencing, selection and repetition. Or three types of structured concepts, actually. Structured programming concepts. Three types of structured programming concepts are there. One is sequencing, selection and repetition. Sequencing we have seen in the previous slide. So S1, S2 or S3 are there. So if the statements are placed in that order physically, then the order of execution of statements will be again S1, S2, S3. So these structured programming concepts made the programs more readable. In what way? So before the use of these control statements, or before somebody introduced these control statements concepts. So use of statements like jump and go to led to what is called as unstructured programming. Unstructured programming. So it led to what is called as unstructured programming. That means there is no proper structure. That means suppose S1 is there, S2 is there, S3, S4, etc., etc. So assume different statements. Assume different statements. So there was no control over these statements. So people have written the programs. So they may execute S1, and after executing S1, they use it to go to S3 or S2 or S4 depending on their requirement. Depending on the requirement. Okay, if you have say S1, S2, S3, S4, only 4 statements, then okay, you can understand. Then you can understand. It may be little difficult, but you can understand. But what happens if you have thousands of statements in a program, and you go from one statement to other statement as you like. You are going from one statement to other statement as you like. Suppose you go from first statement to 999 statement, 821 statement, 767 statement, 544 statements, 998 statement. Like that, you go from one statement to other statement. Then you cannot understand such programs. So unstructured programming existed before the introduction of the concepts called as structured programming concepts. Unstructured programming existed, but it worked for some days, for some years, because the programs that were written in those days were only simple. They consisted of say 10 statements, 20 statements, 30 statements, like that. Okay, to some extent, if a programmer is careful, you can understand the programs. So these statements like jump and go to were supported. Jump was used in assembly languages, and go to in programming languages like Fortran, Pascal, etc. Even C has this go to statement. But of course, the use of go to statement is discouraged. So it's better you don't use it. Jump statement. So jump statement means you can jump from one statement to another statement as you like. We are not going into the assembly language programming. So we'll discuss one example on goto at the end of this session. We'll discuss one goto statement example. But the point to be noted here is using jump and goto, you can go from any statement to any statement. So that led to what is called as unstructured programming, and unstructured programs are difficult to read, understand, debug, etc. So these control statements were introduced. Unstructured programming existed, so structured programming concepts are introduced in the form of control statements. Structured programming concepts are introduced in the form of control statements, which provided user control over the program, control over the execution of statements. Sequencing, the physical order in which statements are placed in the order of execution of statements. And then the second structured programming concept is selection. Certain statements are executed, or certain statements are selected for execution based on some condition. Certain statements are selected for execution based on some condition. They are otherwise called as conditional statements. C language supports two types of conditional statements, or two conditional statements: if else statement and then switch statement. We'll study about these statements in detail later. But two types of statements are supported, or two statements are supported: if-else statement and switch statement. And then the third structured programming concept is repetition or iteration. These statements permit the user to execute some statements repeatedly. That means several times. So they are otherwise called as loops. So C language supports loops in the form of while, do while, and then for. While, do while, and then for. And these statements we have written S1, S2, S3. These statements can be simple statements or compound statements. Simple statement means only one statement. The compound statement means you can group the statements. You can group the statements using these flower brackets. So here, whenever we are saying that based on some condition, a statement is executed, means a statement can be a simple statement or a group of statements called as compound statement. Compound statement. Statements can be nested. That means some statements can be embedded in some other statements. You can write like this. Okay, that means here some statements will be there. Here some statements will be there. Here some statements will be there. Here also some statements will be there. And these are called as nested statements. Some statements will be there here also. These are called as nested statements. So like this you can do the nesting of statements also. C language statement is terminated by semicolon. Statement is terminated by semicolon. So goto statement. Goto statement. So they are the structured programming concepts. They are supported by any language in the form of control statements or control structures. In the case of C language, the physical order in which you place the statements will be the order of execution unless otherwise specified. So otherwise means you can use selection type of statements, you can use iteration type of statements. You can use selection type of statements and you can use iteration type of statements. So the goto statement is supported by the languages. Now also the goto statement is supported, including the C language, but the use of it is discouraged. It is discouraged. So one of the oldest forms of statements to transfer the control of execution from one statement to another is this goto statement. So you can say it is similar to the jump statement that was used in assembly language programming. The format of it is goto label. Goto label. That is this label. This label is nothing but the statement to be executed next. So before that statement you will put a label. Before that statement you put a label. The label is nothing but a valid identifier. Valid identifier. So how do you put it? We will put it like this: label colon target statement. Label colon target statement. We'll consider an example. We'll discuss unstructured programming also. How it leads to confusion. Let us see. So these are some of the references. Which you can follow for control statements. Again, I repeat. So you need not follow only these references. You can have any C language book. You can download it. You can purchase it. Maybe you can use directly the internet. You can see it online. Doesn't matter. Okay. So it's a skill. Skill you have to acquire. That you can do only by practice, but not by just reading the book. So these are the references. So please follow the structured path only. Thank you for this session. We'll continue with the programming. So we'll use Guinea. You can see here I hope it is visible to you. So include stdio.h integer main. This is the skeleton which we always use, But how to do the program? How to do the program? Unstructured programming. I want to demonstrate unstructured programming. Now, how unstructured programming is supported by the languages using goto. Using goto. Let me write printf first statement. First statement. Printf second statement. Second statement. F third statement. Now what happens if I execute? What happens if I execute? So here we'll build. Okay, compilation is okay. So you always use in Guinea, you always use build instead of compiling and then building. So you always use build. If you want to actually create a new file, you can go here and select new. Okay. Now what happens if I execute? So you can say first statement, second statement, third statement, one after the other, one after the other. So that means first this printf is executed, then this printf statement is executed, then this printf statement is executed. That means the physical order in which you have placed the statements is the order of execution of the statements. Now we want to change it. How we want to change it? Suppose I want to execute this statement first. I want to execute this statement. So what I can do here, I can write say go to third. Go to third. Okay, go to third. Now what I do is I place HIRD here. Okay, now let me check. Filing properly. Okay, no problem with the compilation. So execute. So what happened? So only third statement is printed. Only third statement is printed. The third statement is printed. So that means you have written go to here. You are directly gone to the statements. So this statement is executed. So after executing the statements, so what is the next statement? Next statement is there is no statement here. So return 0. So return 0 will be executed. That means control is transferred back. Return statement. If it is just a single function, you can say the function is terminated. And 0 indicates success. 0 indicates success. So it is operating system related concept. Operating system related concept. So whenever a program gets executed correctly, it should return 0. Okay. Now I want to change it. How do you play with it? How do you play with it so that you get confused? Get confused. Okay. Now after this, say I write go to second. Go to second, say. Yeah, these are identifiers. You can use X, Y, anything. Go to second. Go to second. Now what is happening? Go to third. The statement is executed. Again, go to second. Go here. Go here. Okay. So you are executing. Next, try it again. Oh, you have gone into an infinite loop. Now what is happening? You have gone into an infinite loop. That's why you are discouraged. Let me try to stop it. Okay. Stop it. The control C. Let me try again. For your sake. For your sake. Okay. Good. It is going. Check control C. Okay. Control C is working. So it terminates the program. In the Guinea environment, Control C terminates the program. If I accidentally go into an infinite loop, so we have to use Control C. Okay, that please remember, note down Control C. Okay, so what is happening here? Go to third, I gone here second. Okay, go to second. So go to second, I come here, I will execute it again. I will execute it again. Again, this statement is executed. Printf statement is executed. Third statement is executed. Again, go to second. That means again I am coming back. So that means, so I am printing these statements repeatedly. That's why we are going into an infinite loop. We are going into an infinite loop. Okay, maybe what I can do is here again I can write go to. Okay, go to, I can write say last. So maybe I will try it. Last, there is nothing. Whether it compiles or not, let us see. Okay, good. What is happening? Third statement, second statement. Third statement, second statement. What is happening? So go to third. This third printf third statement is printed. Go to second. So go here. Second statement is printed. After that, go to last. Go to last. That means control is transferred here. So there is nothing here. So nothing happens. So program just returns. Program just returns. So if you consider this one, this itself is little confusing. We have just written 3 printf statements only, but still it is confusing for us. So if you write 1000 lines code, then if you use goto statements as you like, then it will lead to programs which are difficult to read, understand, which may not execute properly. And if you try to find the error, logical error, it's difficult to trace actually. So always avoid use of goto statements. Except there is no choice, don't use them. Except there is no choice, don't use them. Okay, this is regarding the unstructured programming. So our use of goto. Okay, thank you.